This is Craig Migliaccio from acservicetech, and today we're going over the full installation of this Cooper & Hunter outdoor inverter mini-split heat pump unit to this indoor ducted air handler. Now this air handler has been designed specifically to work with this inverter unit. These are both 2-ton systems. We're going to be going over the connections for the ductwork, the line set, the electrical wiring, and the thermostat wiring, as well as the entire installation, step by step. The first thing that we want to do is locate our indoor unit in correspondence with our outdoor unit. And so we've already drilled a hole here, we've already put a PVC sleeve through, we had an electrician mount the electrical disconnect, and we have the outdoor unit in place. And so we can take this line set and push it through the sleeve, and then we're going to be bending around this unit, and this air handler is actually going to be up on top of this return plenum, and we're also going to be using a condensate pan for condensate protection. And so we can go ahead and get started with our job. What I'd like to do is get the indoor air handler up on top of this return air box. Now this box was made to size to fit the opening on the bottom of the air handler. We're going to take these little feet and we're going to put them on the bottom of the box to keep them up off the ground. And then we're going to take our filter return air grills and we're going to cut them into the sides of this return box. And so the point of that is to hold the filter, so that's the air filter, in place, and we're going to be able to pull air from this room. So the next thing we need to do is mark this hole out, cut the hole, and mount these grills in place. You can use these pan head screws instead of the 1/4" zip screws because that'll not protrude into your filter area as much and get caught on the filter. Before I try to screw this into the air handler, I'm going to make myself a couple of little holes so I'm not struggling when I'm trying to screw from the inside here into the air handler. I may even make a hole here and a hole here, but I'm not sure if I'm going to use those. Once these feet are in place, we can just lift the unit up. I'm going to wait till later to put the supply plenum on and also to seal down at the return plenum. And next we're going to install the line set. Now we'll bend this line set straight. Next we're going to check the condition of the flares, and so you don't want to just put them onto these service valves, you want to check them first. And so you know, this manufacturer has pre-installed the flare nuts onto this line set, and these are the same flare nuts that are on this system. If you buy the line set separate from the manufacturer, you may need to cut these off and install the manufacturer's flare nuts. So that 3/8 one looks good. The 5/8 one, I'm going to make that a little bit bigger, so I'm going to use my flaring tool for that one. This here is an eccentric flaring tool, and they make really good flares. That's a lot better. So just to give you a look at what happens with an eccentric flaring tool, this little cone kind of pivots and it makes for a really nice flare. It doesn't put a lot of surface tension on the copper, but it kind of just rolls it out in order to make the flare. I'm going to bend these into position and put these on, but I'm not going to tighten them. I'm just going to kind of screw them on so that I can do my line set bending inside the building. I'll come back and torque these down later. That's enough. I just want to hold it in place. I just want to make sure that it's not too short after I'm done my bending inside. It's very important to also make sure that your flares are lined up properly on the flare adapter, that they're not kind of off to the side or something like that. But these two are lined up pretty good. So we're just going to hold these here. We'll come back to them after we're done bending inside. So we're going to be bending this line set along the wall here. It's going to come behind the air handler and then it's going to bend this way. So we'll make our first bend. What you want to do is you want to keep moving your hand every time when you're doing your hand bending. So you don't want to end up with a kink in one spot. There we go. Now to make this easier, what you could do is you could just bend one at a time, but I'm just trying to keep these lines set together. Now that I marked my line set, what I'm going to do is I'm going to separate these two. I'm going to cut each one, and I'm going to then do my final bends from here into the flare adapter, because we have to kind of bend inwards and then go straight into these adapters here. Every time that you go around with a tubing cutter, what you want to do is you want to turn this maybe 1/8 of a turn or even 1/4 of a turn. You go around and then you turn the wheel again, and basically you're pushing the wheel as it's rolling into the copper more until it ends up penetrating through the copper. So this is a little mini tubing cutter. There it is. So those are clean cut flares. Now we're going to need to use our deburring tool in each of these tubes as the tubes are pointed downwards, so any shards that are inside the tube fall out of the tube. So the other thing is we want to make sure that this is basically just going downhill the whole way. You don't want to go up and down. We're just going to keep this nice and straight or slightly pitched downwards until we go outside. The next thing I'm going to do here is I'm going to cut my flares. After you cut the back of the insulation, you want to put the flare nut on first. You want to make sure not to forget that. And then we're going to take our flaring tool and we're going to open it up and set this in the 5/8 tray. Next, we're going to slide this tool down, and we want to lock this in place. So right there. So the whole point of this is you want to get the copper tube to the end of the block, so right to the edge. We move this down, we lock it in, and then as we turn this in, the eccentric flaring tool is going to be rolling out the copper. Now you're going to see this little clutch right here open up as we are tightening in. It's not going to allow the copper tube to end up getting squeezed too much. So you can see the clutch is already opening up. It's not going to allow you to over tighten this. So you can see it's open now. See, now we need to back off. It's important to get the cone that's up here out of the way completely so that you can take this tool and slide it up. Pull this up. We can open this up, and then we can pull the flare nut over. And so the whole point is you want to make sure that this flare nut is actually able to go over the flare. So it's able to, that's not a problem. Next we'll take our 3/8 tube and we'll put our flare nut on. We're going to open this up. 3/8 is right here. And you see this slide is able to go over the tube. That means we're good. You just want to squeeze this block tight. Then you can slide this up. Tighten the wing nut. And we're going to tighten our handle. Hopefully you can see this. Now we're going to loosen it. It's very important to use a flaring tool that's not going to scar the face of the flare. So that's why I really like to use this eccentric flaring tool. Next we're going to look at the positions of these service valves. And so you can see that the inner cylinder is backed out all the way. It's actually not a backseat position, it's just in the fully open position. You never want to force these because there's a little lock ring in there. But anyway, the whole point of this is that this service valve, which is the vapor line, and this one right here, which is the liquid line, are open. And you see on these caps right here, this little red button, that means that there's pressure inside, meaning nitrogen pressure. And so we're going to want to remove this. So that's just nitrogen. Now if you were curious to see how much pressure in nitrogen this had, you could put a gauge right here on the side in order to measure it before you remove these caps. But in this case we are good, and this evaporator coil doesn't have any leaks from the manufacturer or anything like that. So we're good to go to connect our flare adapters. I'm just going to put this back on. There's not much of a need to be working on that right now. So we're going to take this, and we want to make sure that our flare adapter makes it over here. So we're just going to do any final bending in order to make sure that takes place. So the whole object is you want to make sure that once this thing's in place, that this line set's not going to be moving on you while it's running. And so we're going to end up putting a clamp in the back to hold this once we get this all into position. But this looks pretty good now. It looks flat and straight on the flare adapter, so that's good. So that looks pretty good right there. I don't know if you can see that. The next thing that we're going to do is we're going to turn our torque wrench on, and we have our memory settings. So we're going to go to memory number 2, which is our Newton meters for our 3/8 line. So that's right here. So we have it set at 25.5 Newton meter. And for that tube size, so that's 9.52 millimeters, that's the same thing as 3/8. You can see we have 25 to 26 Newton meters. So we're going to hold back with a adjustable wrench. In order to do that, we're going to put this cap back on, just like that, and put an adjustable wrench on. Now this torque wrench is going to beep, beep, beep until we approach the correct torque value, and then we're going to have a solid beep. You should be able to see on the display. I don't know if you can see it or not. You can hear it starting to get close. I'm going to adjust my adjustable wrench here on the end. Here we go. So you can see we're right there. So that's it. Now we're going to go clear this, and then we're going to go to our memory setting number 4. So that's 46 Newton meter. And that's for our 5/8 line. So we have 16, that's our pipe size in millimeters, so that's 5/8. And then we have 45 to 47 Newton meter. So we have 46 set right here, and of course you can set this for whatever unit that you want, for whatever system that you're working on, just in order to follow the installation guidelines. So here we go. That's it. So the secret to this is making a good flare and inspecting the flare and inspecting the flare adapter to make sure there's no scratches and tightening these down to the proper torque value. If you do that, you shouldn't have any leaks, and you don't actually need gasketing material between the copper and the brass, because the copper acts as the gasketing material itself. And so you just want to make sure these are torqued down to the proper values, and then we're going to do a leak test after we're done connecting at the outdoor unit. So we'll be able to verify if we have any leaks at our joints. Next, we're going to take these flare nuts off and just see if our flare is still aligned properly, which it is, and it looks real good. It's covering over the flare adapter. It's actually going past it a little bit. So looks like we're good. Actually, you know what? What I'll do is I'll bend this up just a hair more. There we go. That looks good. Let's take a look at this one. That one looks good as well. So you want to make sure that that flare is fully covering the flare face. And the other thing is, I just want to point out that this connection right here doesn't need anything additional on it, and you never want to put anything on these threads because that's going to negatively affect your torque value when you're trying to tighten these down. So let's go ahead and tighten these with our torque wrench. Now what I want to show you out here is that these service valves are fully front seated, so the cylinder is all the way in, and that means it's holding back the refrigerant charge in this outdoor unit. And so we're not going to be touching that until after the vacuum procedure is done. And we're going to put our adjustable wrench on here because now we're getting ready to torque this. And so we need to turn our torque wrench on. And so the next thing we're going to do is we're going to make sure that it's set on 46, which it was. That's 46 Newton meter for our 5/8. And so that's where we left off at. We're going to tighten this on. Now you're not going to be able to see the lights this time, but you're just going to listen for a steady beep noise. So you're going to hear beeping, beep, 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 and then you're just going to hear beep, and that means that it's fully torqued, and I'll show you the torque value after we're done. So we actually torqued a little bit too much. We're at 51.3, but we are torqued down to the good amount on this 5/8 copper tube. Now what we want to do is we want to change our setting. So we want to come all the way back to memory. So that's in the bottom right hand corner. So that's for a 1/4 inch. This is for 3/8. So that's 25.5 Newton meter. And then we're going to attach right onto this 3/8 flare nut. Once again, I'll show you the torque value once I'm all done. So it says 26. So we're good here. So now we need to leak test in order to see if we have any leaks at our flare joints. Next we're going to do our pressure test, and in order to do that we're going to need our nitrogen bottle, and then we have our tank pressure, then we have our pressure that's exiting the regulator. So we want to make sure that this thumb screw is backed out so that we can then open it up, and we're going to take a hose with a little ball valve on the end. We get that closed. We're going to turn this in, and we can just push this up to where we're going to pressure test up to, which is about, say, about 300, 325. And I'm going to show you why. The reason is up on the indoor unit rating plate, there's a design pressure of 340 psi. That's for the low side. Now, at the outdoor unit rating plate, there's also another rating plate there that says design pressure on the low side, 340 psi. So this is a new system. We don't want to exceed whatever the lower of the two design pressures are, and so we're just going to pressure test right up below that at about, say, 325. So we're ready to go ahead and connect this onto our port. The first thing we want to do is we want to take this port cap off. Now I'm going to be using valve core removal tools, and I'm going to be also using this valve for during the pressure test. But what we're going to want to do next is pull this valve core out so that we can remove this restriction. We're going to leave this out for even during the vacuum process. I just want to get it out now. Now, if you don't use a valve core removal tool during your pressure test, you could just use a 5/16 to 1/4 inch adapter. So that would press in on the valve core here, and then you have this on this side. You could use a manifold gauge set. But in our case, what we're doing is we're going to be using a digital pressure gauge because it's very accurate. So we're going to attach this on right here. So this is a 5/16 end on this tool right here. This is valve core removal tool, and I'm going to take this right here and attach this on the side. Now some mini split units have a 1/4 inch port instead, and in that case you'd use a 1/4 inch valve core removal tool. Now the next thing we're going to want to do is we're going to want to put this right in here. And so I'm not going to tighten it in all the way yet because I want to just purge the air from in this tube. I'm going to tighten it on. Open this up, and we're going to turn our digital gauge on, and we're going to increase the pressure. At first you might want to just do it up to, say, somewhere around, say, 50 or 100 psi, and you just want to see if you're going to have a sudden drop because maybe you didn't connect one of the flare adapters or something like that. But in this case you can see we're good. So we're going to go ahead and target right around 300, 325. So there we go. What I'll do now is I'm going to turn this to the off position. I'm going to disconnect this. And we want to let this stabilize. You got to remember that the nitrogen tank is at a different temperature, maybe if it came out of the service truck, than the system's tubing. And so really what we want to do is we want to give the nitrogen a chance to settle and be in the tubing. That's a different temperature. And then after about a minute or 2 minutes, once this pressure has settled down, because it will move based on temperature, once it's settled down, we'll wait 10 minutes and do a 10-minute standing vacuum test. So we're at 327.5 right now. We're going to wait 10 minutes and do a 10-minute standing pressure test. And so we'll just go ahead and let this sit. So if we have pressure falling, that's going to indicate that there's a leak potentially. And the other thing is we can go inside the building and at these flare connections here and put on some bubble leak detector and to see if there's any bubbles leaking. If you were to use a compound gauge, I would highly recommend putting bubble leak detector on the joints. But a digital gauge is going to be able to show any small incremental changes in tenths of a PSI. So that's why we use it. All right, we'll let this sit for 10 minutes now. So I let this run a little while longer. You can see we're reading 327 PSI, so we are good. So we can just go ahead and stop this. We had an initial fall in pressure, and that was just because the bottle was outside, and it's hotter outside than it is inside. It's about 85 outside, and it's about 70 degrees inside. And so once that stabilized, it stayed right about 327, so that's good. And so then we can go ahead and let this pressure out, and then we'll get our vacuum setup attached. Now our pressure test is done. We have no leaks. If we did add bubble leak detector, there would be little bubbles forming or glistening on the flare joints, but in this case we're good to go. So now we're going to detach this pressure gauge right here, and we're going to attach another valve core removal tool. And the reason I do this is because I like to use the valve, which is rated down to 20 microns, in order to protect the vacuum gauge. And so I've already removed the valve core out of the side of the tool, and now we're just going to add this right here. And so I'm not pulling a vacuum through a manifold because I don't want the potential for leaks to occur. Their manifolds are really meant for positive pressure for the most part, and sometimes they end up having problems with leaks, so I just try to avoid that. So we'll attach this here, turn that on. I'm going to put this on the top of the unit so we don't lose it. And here we have a 3/8 hose with a 1/4 inch fitting here and a 3/8 fitting here. So we're going to attach this. Right here we're using a larger hose diameter in order to pull a faster vacuum. You see this vacuum pump has a little T here, so you can use a variety of different hose sizes. So we need to get below 500 microns, but we're going to target a little lower than that, around 200 to 300 microns. You can see our units are already on microns right there, so we should be good to go. Let's just check our connections. We're not going to add the valve core back in to this port until after the system has positive pressure. So after we pull the vacuum down and we make sure it's holding below 500 microns, that's when we're going to open these service valves up. So let's turn the vacuum pump on. Now we're doing our 10-minute standing vacuum test, and we're going to see if the micron level rises dramatically and rises up above 500 microns. So what we've done is we've valved off the vacuum pump and we've turned the vacuum pump off, and so now we're reading the true vacuum level within the system. And so if this doesn't rise much, then we're going to be good to go as far as opening up these service valves. So we just want to go ahead and wait our 10 minutes. You always want to think about that the 10-minute standing vacuum test, or also referred to as a decay test, is going to give you the true vacuum level, and when the vacuum pump's running, the vacuum level is going to be lower. So with the vacuum pump off, you can assess what the real vacuum level is. So our 10-minute standing vacuum test is done. You can see that the micron level did not rise, and so we are good to go in reference to opening up these service valves and allowing refrigerant to go from this outdoor unit to the line set and to the indoor unit. Now this unit has been equipped with enough refrigerant for this amount of line set. So we have right about, say, 8 foot of line set. So here we go. So we've turned this off, and now what I'm going to do is I'm going to valve this off in order to protect my vacuum gauge from any oil and refrigerant from coming up into it. So just so I don't have to re-clean the sensor. So I'm just going to turn that to the off position, and then I'm going to open this up counterclockwise, and that's going to allow refrigerant throughout the system. Now when I back this up, you don't want to back it up like all the way like crazy and push on it, because there's a little split ring there. You're just going to end up popping that split ring out, and that whole cylinder could shoot out, and that's obviously no good. So we want to try to avoid that. So we're just turning it back, and there's a little O-ring in the cylinder that seals in the refrigerant. So now that the refrigerant's inside the system, we can go ahead and put this valve core back into the port. We'll take this and we'll push this nut forward, and we're going to put our valve core back in. And then we'll open this valve, and we want to purge the air out that's right here. So we don't want to force that into the system. And then what we're going to do is we're going to push inwards while rotating this clockwise. And that's going to screw our valve core back into the port. Basically, you're fighting the pressure in the system. That's why you got to push in as you're rotating this clockwise. So next, you'll let that go. We're going to shut the valve. And then we can put a port cap on, and this port cap has a hole in it. And we're going to do this to test if that valve core has any leaks. We can go ahead and open that, and we'll add our bubble leak detector onto the end and see if any bubbles form. So we're good to go now. We'll go ahead and take our valve core removal tools off and put our port cap back on. We're also going to put our service valve caps back on. Now we can move on to our next step. Next, we're going to work on the electrical wiring. So we're going to work on the power wiring from here to the unit, and we have to run the power wiring through flexible conduit. And we're going to be running 10 gauge wire because of the max fuse or the max breaker size of this unit. So first step is to verify that our power's off with our multimeter set on voltage. And so we're going to go from one to the other. We see no voltage. And then from one leg to the ground, no voltage, and the other one to the ground, no voltage. So right now the breaker's off. The next thing that we need to do is dry fit this seal tight. So we're going to go from here. So we have these two holes already mounted. This is an existing disconnect box. and we're just mounting to it. And we're going to be running this seal tight down to the line set and then up, right up to here. And so we can go ahead and cut that with our PVC cutter. And so I'm going to cut this to length right here. And next we're going to need to fish our wiring through this. So we're going to need 2 legs and our ground wire. And so we can just run our electrical lines through here. We're also going to be putting surge protection on this disconnect box, and that's going to be on the load side, which is the wiring that's going to this. See, we have this just in the non-connected position right now, but first I want to connect and run my wiring here. So we've electrical taped all of our wires together, and we're going to stick them in here, and we're going to fish through to the other side. All right, so we got out the other side now. So these are good. These wires are referred to as THHN wire or THWN. And so these are the ones that you would want to use. These are stranded wires. And what I'm going to do is I'm just going to cut this down. So now that we have this here, we're going to also want to put our section of our connector. So this is going to go here, and this is going to go on the end. So we're good to go here. Now I want to put my connectors in here. We're going to need one for the power wiring and one for the communication wiring. This is 10 gauge. We're going to put this back on just temporarily, and then we're going to move up to the upper disconnect, and we're going to work there. We're going to come back to this to do the communication line afterwards. So we're mounting our surge protection on this electrical disconnect in order to protect the outdoor unit printed circuit board from any lightning strikes or over voltage. Now check with your local jurisdictions as far as who can do the electrical wiring from the disconnect to the outdoor unit and install the surge protection, but in this case a master license holder in the state of New Jersey is allowed to do this. So this surge protection is there in order to protect the mini-split control board from any, say, lightning strikes or anything like that, and this goes on the load side. So that is the one that's connected from here to the outdoor unit. Even when the disconnect is pulled, this surge protection is protecting the outdoor unit from any high voltage spikes. Next, we're going to be dry fitting our flexible conduit so that we can know how long it's going to need to be. In order to do this, we're going to just fish it outside, right to the outdoor unit. We're also going to be just keeping this straight and then putting the wiring, the communication wiring into this. So first thing we want to do is dry fit it for length. Next, after that, we'll fish our wiring through. We're going to pull this line set and we're going to end up zip tying it right to the line set tubing. But right now I just want to get length. So I'm going to go right here because I'm going to have a 90 fitting right on the end. And we're going to be using the cabling right here that came with the units. And the reason that we're putting this flexible conduit on is to protect it both inside and outside. Not only is it low voltage communication wiring, but it's also the power wiring to this unit. And so outside, once again, you want to have protection, and some codes require that. Now, instead of having seal tight around this, you could use something like this. And this is kind of like an armored cable. This is Southwire Easy In, and you could cut some of this plastic back and you'd be able to see the MC, so the metallic clad here protecting the wire. So you could use something like this instead of this wiring with the electrical conduit on the outside. So anyway, this is what we're doing. I'm going to go ahead and fish this wiring down through my conduit. So I may end up pulling this straight back on the other side again, just in order to fish this through. It'll make it real easy for me if I just hold this straight. Just going to go ahead and pull some of this out. We're a little bit too far. So that should be good. So we can cut the wiring here because we're going to be taking this and bringing it in here in order to wire this in. Let's move to the outdoor unit and just finish wiring that, and then we'll address this right here. We'll put all this in and connect it to the indoor unit. So in reference to these colors, you have black on 1, white on 2, and red on 3. So this color scheme for the numbers 1, 2, 3 are going to be the same at the indoor unit. What I'm also going to do, I'm going to straighten this little red wire as well, but that's it. So now we can put the cover back on. So I just put this screw in, and I'm putting my second one in. Next, we're going to add our 90 into the side of the unit so we can bring our communication wiring to those indoor terminals. The thing to keep in mind is that you may be required by code, and you got to check with your local jurisdictions on this. You may need to have a disconnect switch on the air handler, even though this wiring is not coming directly from the breaker box, but it's actually coming from the outdoor unit. Now that outdoor unit has a disconnect on it. It's right behind this wall, right on the other side. And if you were to pull that disconnect, it's going to shut off both the outdoor unit and the indoor unit because this power and communication wiring is coming from the outdoor unit itself. And so that's something you need to keep in mind, but this is actually going to be wired just like an indoor wall hung unit would be. And the terminal number 3 is actually a very low voltage direct current signal from this circuit board to the outdoor circuit board. And it's actually going to be using the 3 and the 2 in order to talk back and forth with each other, in order to operate. Also, 1 and 2 are the main power wires from the outdoor unit to the indoor unit in order to allow the system to even be powered and to run. So that's all happening on this wire right here. The one thing to keep in mind when using a switch is that maybe down the line you may have a communication error between the indoor unit and the outdoor unit just due to some high electrical resistance across the contacts. So I just want you to keep that in mind, but you're going to have to install this if code requires it. We don't need a whole lot, so I'm going to cut this down just a little bit. Hopefully you can see that. We're putting it on the red terminal on the crimping device. You always want to check your crimps afterwards, pull, and make sure that it doesn't slip out. Now we're going to move on to wiring it in at our terminals. So we're doing this the same colors as the outdoor unit has. So we have black on 1, we've got white on 2, and red on 3. So it doesn't really matter what color wires you use where. You don't have to worry about the colors on this side here, just what's on the right side. We're going to be adding these condensate safety switches to this unit, and in order to do so on this particular system, we removed that J1 jumper right above this green assembly, and we're going to be wiring the 2 safety switches in series with this block and then putting it into the terminal here. It's going to be on the 2 outermost terminals of the 3 here. We're going to mount 1 safety switch at the slightly higher port, the drain port, on the bottom of the indoor coil pan. And so we're going to mount this in, and so this has already been primed and glued together, and I have Teflon tape on the threads, and so you just want to hand tighten this, and then you can just give it just a hair of extra torque, but you don't want to over tighten it because you don't want any leaks at your pan. And we can put that right in here. We're mounting this safety switch in the secondary pan, so this is the emergency condensate safety pan. This is the condensate cup. So you just snug this in, then you want to make sure that this right here is pushed down all the way to where it's touching the bottom of the pan, and then we can take our wiring and we're just going to mount that right up onto the box here. We'll use some little clips. We'll put a few of them up and come right up the side of the unit. So when you're putting these little clamps on, make sure that you're not going to put a long screw in and screw into the indoor coil, so you just want to pay special attention to that. Now I'm going to put a little duct plug in, and that's where our small wiring right here is going to enter the electrical cabinet. So we have our connector right here, and these 2 switches are in series, and you can see that our one wire is on the outside and the other one's on the other side. So we're ready. And that's it. So our condensate safety switches are monitoring, and we're good to go. What I like to do with this stuff is I like to get on both sides of it, kind of hold it together in order for it to snap in like that. Now I'm going to put some duct mastic on the back of this. You can also put tin tape on it, and just in order to hold it tight. Next we're going to do the crimping on here, because as you can see, this will not go directly on top of this. We're going to have to make a crimp just like this is. When you're using a 5-bleed crimper, the 2 have to go inwards and the 3 are on the outside in order to bend it inwards. Let's see if that's crimped enough. It is. What I like to do is come on both sides of this snap lock right here, just to make sure that it's never going to open up. And once again, you want to put tin tape or duct mastic on here as well to seal the rest of it. Let's take this and mount it to the unit, you're going to want to use zip screws. So these are 1/4 inch zip screws. You could use 1/4 inch or 5/16. You want to use ones that have a drill bit on the end so it can go through multiple layers or thick sheet metal without a problem. Also make sure that you don't use real long screws that are going to penetrate too far through. So these are still going to be good because they're going to go into this area where there's 1/2 inch insulation. Next we're going to take our duct mastic and we're going to seal up any sections in our duct here. So this is going to be able to tie into the existing ductwork up above. Next we're going to be doing our mastic. So this is water-based sealant. I like to use it in a caulk tube. It's the easiest way to put it on. And so it's going to come right along our seams. I like to use gray because obviously it matches the color of the equipment, so it doesn't stand out too bad. You want to be real careful when you're rubbing your hand along here. Make sure you're wearing protective gloves because you could have a little shard of metal or something like that, and it all comes down to how well you cut the edge of this sheet of metal. Anyway, now we're going to move down to our return. Now in order to seal around this return grill, I'm actually going to use clear sealant because I don't want to mess up the colors on this. But in reference to just the duct to metal, and especially areas that are going to be insulated, it's certainly good to just use the mastic there. For this supply plenum from here until the ceiling right here, it is within the conditioned area, so it doesn't have to be insulated. But I would actually be putting some bubble wrap insulation around this area just so we don't get some droplets that are coming down, because this is going to be much lower in temperature than the surrounding air. But I'm going to be doing that at a later date. So we need to insulate these two service valves. Remember, during air conditioning mode, both of these are going to be low in temperature, so it'll cause humidity to be attracted, condense, and then drip off of this down onto the floor. That could cause building damage, so we want to go ahead and insulate that. And so I used the back of this just because I wanted to be able to slide, and we'll come and insulate the front of this differently. Now these two and these two are already tight. We've already checked that, everything's good there. You can also take a little bit of sealant and put it right around the perimeter as well. This is all insulated on the inside as well. You could also pack in here. We've already removed this air filter from the system. It was located right in here. If you were going to use this chamber for the air filter, you wouldn't be able to put a trap here. You'd have to put it over here on the side. But in our case, we have our filter return air grills right over here on the side. So we got one on this side and one on the other side. So we've got our pleated filters in. We've got a lot of return air space so that we have a low airflow friction for this system. But anyway, this condensate line, basically what's happening is during air conditioning mode, the coil that's here is low in temperature, and the humidity in the air crossing the coil condenses to the coil, and it drips down into this 3/4 PVC and drains out of the system. And so you want to drain that to the outside or in a drain, but you're going to need a trap on these negative pressure systems, such as an air handler. It has to have water weight inside, so that while the system is running, this pan does not overflow on the inside and drip down into the inside of this unit. We've also have a clean out tee right here, so you can clean this trap out in the future. You got to make sure also that this condensate line is pitched 1/4 inch of pitch per foot downwards until it exits through the building. So what you're looking at is the thermostat wire. In this case over here, we got 16 gauge, and then this one's 18 gauge. And so we didn't end up using 18. We ended up running 16 gauge wire, and this is stranded wire for the communication to the thermostat. And it's only 2 wires. So what we're going to do is we're going to put these in right here on the HA and the HB. And so right underneath these terminals right here. You want to use stranded wire for this so that you don't lose the low voltage direct current signals between the thermostat and this board right here. We could also use crimp connectors here, but we figured since there was no room at the thermostat, in order to put crimp connectors there, we're just going to go ahead and wire this right in. All right. So that's that. Next, we want to go ahead and install our thermostat on the wall. We've already run our thermostat wire across the ceiling, over and down inside the wall, and so now we need to mount the thermostat in. Next, we're going to be installing our communicating thermostat, and so we have this on the wall right here, and we're going to make sure that this is level. So we're good to go there. And we have a horizontal section of wood, so we should be good somewhere around in here. And we're going to cut this out right here with a keyhole saw. We're going to make the inside a little bit bigger. The next thing you want to do is get an insulation hanger or a coat hanger in order to try to grab around and see if you can feel the thermostat wire in order to hook it and pull it out. Oh, I can feel it right now. There you go. And so right now that thermostat wire is actually heading downhill, and that's the whole point. You want to have a little loop in order, it's like a drip loop in case anything was to ever leak onto that wire. You don't want it to leak into your thermostat. So what I'm going to do now is I'm actually going to tape my insulation hanger onto the wires just to make sure that I don't lose them down inside the wall. If you want to learn about fishing wires, thermostat wires, I have a whole nother video on that, link down in the description section below, so make sure you check that out. So we're going to mount this in. So we're good to go there. Next, we're going to be screwing this into the back of the thermostat. Now, normally you're going to use crimp connectors, but in this case, you're not going to have the space for that. So we're just going to have to try to fit these underneath of the terminal. You want to twist it real nice and tight. Next, we're just going to put some thumb gum in the hole here in order to seal this up in case you have any warm air or anything like that. That's going to affect the actual temperature reading inside the thermostat. You could also use silicone or just something that is non-conductive. Next, you're going to want to slide the battery in. So that's good. So we're good to go. This control board right here, you could end up using a regular 24-volt thermostat, and so we didn't do that because we want more efficiency and more control, so we are connecting it over here to the low voltage direct current communication between this board and the communicating thermostat. So now we want to set any of the dip switches, and this right here is going to remain off because we're not using a 24-volt thermostat. We don't have to change the address because we only have one air handler connected to the one outdoor unit. These right here are function dip switch settings, and then this one right here is only for the static pressure for if you have electric strip heating in order to control the air volume for the strip heating size that you would use. In this case, we're not using any electric strip heating, and we're specifically powering this air handler with the power from the outdoor unit. There's different models of these types of air handlers that you can get, so we're going to leave all this alone down here because we have no electric strip heating. So right here, we got this block right here is SW1, this is SW2, this is SW3. So SW1-1 is we're going to leave it off because we are not using a 24-volt thermostat. So SW1-2 is for a continuous fan, so we're going to leave that off because we want the fan to shut off after the unit shuts off. So like when the compressor shuts down, the fan is going to end up shutting off as well. SW1-3 is on if it's air conditioning only and off if it's a heat pump model, so heating and cooling, so we're going to leave that off. SW1-4, because this control board communicates with the outdoor unit, we're going to leave that in the off position. SW2, this is all auxiliary heat dip switches, so we don't need to touch those. Those can all remain off. SW3-1 is for increasing the set temperature, but we're going to leave that at default, which is off. SW3 has to do with Y2, and since we're not using the 24-volt thermostat, we don't have to touch that. Same thing with SW3-3, it has to do with W2, so we don't have to worry about that. And SW3-4 is not valid, it won't change anything. So we're going to leave all this alone. So in this case, we didn't have to adjust any dip switch settings, but you always absolutely need to be aware of that, you know, because on a lot of units you have to set the dip switches. On this particular one right here, we didn't have to set any. What we are going to have to do though is we're going to enter our engineering mode using our remote and the display board right here, and we're going to do a setting for our fan. So I'm going to turn the unit on. So we're going to first press our power and our fan. So that's what we're going to have to do to enter the modes. We're going to hold this for about 7 seconds. Now what we're going to do is we're going to select number 2. That's going to take us into our fan motor settings on this particular unit. Then we're going to we're going to hold the power button for 2 seconds. Now that we see CH, we're going to go up. We're going to choose 1. We're going to press OK. And we want to see C5 over here. So we see C5, so we should be good. And now we're going to press and hold our power and fan in order to get out of this mode. And now we're good to go. So what I'm going to do now is I'm going to put this cover on and I'm going to go over to the wall remote. So here we are over at the wired remote controller, and so we have our remote as well that you can use. You just got to make sure you point that right there if you're trying to set the temperature. But for right now we're just going to focus on this, and in order to set the time, we're going to just press this in and hold it, and we're going to go over to Tuesday, which that's today, and then we have our time, and it is 4:42, so we're just going to hold this up. So really that is 16:42. There we go. So you can just leave this flashing and it'll actually just go ahead and sync up. Everything's good there. But what we can also do is we're going to change it from the military time right there. We're going to press both these buttons, the timer and day off, and that's going to make it 4:42. There's timer settings in here, so you can just press this. As you can see, you can adjust that stuff, so that's available as well. Now we're going to go ahead and turn this on. You see we have this set for 83. We're going to turn the temperature down in the building to 72. And that's it. So there's child lock functions and other settings that you can adjust in here, but we're just going to keep it simple and just run this in air conditioning mode now. The fan right here, you can turn it up or you can just leave it on auto. Just going to leave it right about there. And so now our system's running. We'll let this system run for about 5 to 10 minutes, and then I'm going to go over to the air handler and take a delta T measurement there. We have about 20-degree delta T between the supply duct and the return duct of this air handler. I hope this video has helped you understand how these inverter mini-split systems work, and if you want to learn more about HVAC and mini-splits in general, make sure to check out our website over at acservicetech.com, where we have a bunch of articles, quick tips. We also have a new book on mini splits coming out, and so make sure to check that out. So that's going to be in a few months. If you're looking for any of the equipment that's used in this video from Cooper and Hunter, check out the description down below. We have a bunch of links down there. So hope you enjoyed yourself. We'll see you next time at AC Service Tech channel.